All right, so notes 2, 3, segments and distance is really the first video, the notes that we have. Gets away from vocabulary and actually uses a little bit of math. Today is mainly going to be talking about line segments, and there's several ways to find lengths in line segments. But let's remember what a line segment is. Remember, a line segment is just a part of a line. Remember, a line goes on infinitely in both directions, but this is just a part of a line. It consists of two endpoints and all of the points between them. So let's just remember that real quick. If I have a line, it's got the arrows at the end. But if I have a line segment, it's stuck in between these two endpoints, okay? Remember, if that were A and B, we'd say segment AB, just so you know. You can do this a couple of different ways. It says to measure the length of the segment, you can use a number line to find the distance between two endpoints, or you can use this formula. D stands for distance on a number line. It's the absolute value of A minus B, where A and B are the endpoints of the segment. So absolute value is really important here, because if I look back here and I make a number line, maybe I don't need that at the end, like -1, 0, and 1. Well, if I said what's the distance between 1 and -1, you'd probably say -2. Well, absolute value fixes that. Absolute value is really distance between two things, okay? That's why we use it here, because it makes everything positive, right? Like, if I drive from Stephenville to Dublin and back to Stephenville, I didn't drive 0 miles, it added all together. So let's see how that works in the next problem. By the way, this formula is not on a formula chart. You need to know it, but I think you can figure out other ways to use it if you need to. It says find the distance between -2 and 6 on a number line. Now, this one's pretty easy. I'm pretty sure you could figure it out. I'm going to write distance equals the absolute value. Order does not really matter, so I'm going to say -2 minus 6, which is actually the absolute value of -8, which is actually 8, which is the distance. Now I'm going to do it backwards just so you can see it doesn't matter the order. Now I'm going to say 6 minus -2. When we subtract the negative, we call that a boom boom, which is actually absolute value of 8, which we should know is 8. Now you can draw your number line, that's fine. You can count if you want to, but this really is a quick formula. A lot of times you don't even have to write it down. So real quick, we're just going to kind of look at a couple of these. I want to point something out real quick, because look how they have the notation here. It's just PQ. If you say segment PQ, that's naming the segment, okay? If you say PQ without it, that's insinuating that we're looking for length, okay? So if you just see the numbers without the notation, that's looking for length. So from P to Q, well, this is actually pretty easy. It looks like it goes up 1 unit and a half, so I'm going to say 1.5. But just for practice, let's see, that's -3.5 minus -2. We got a boom boom there. That gives us the absolute value -1.5, which of course is 1.5. So I think you can probably figure out the other ones on your own. If you're not watching this, you can always fill in the work if you're having trouble when you come back. For Q to R, I got that it was 4.5, and from P to R, I got 6. So just remember, guys, you cannot have negative distances. It doesn't matter which way you're going. Always positive, okay? Let's go to the next page real quick and look at another type of distance. Sometimes when we have them, they're drawn on the coordinate plane. You've seen these before, like maybe I have a line that's something like that. Well, it's not so easy to count because it's, going catty corner across the XY axis, sorry. So we have a formula for that as well. So this is for, if we're using a coordinate plane, it's the square root of x2 minus x1 squared plus y2 minus y1 squared. If you do that, you can find the distance on anything. This is on the formula chart that I'll give you sometimes, and this is what it's for. It has to give you 2 points. Like over here, maybe this was point -3, -2, and this was point 46. Well, this is going to use our x1, y1, which is just picking one of the points. Maybe this is x1, y1. And it's also going to use the point x2, y2. So that 1 and 2 just signifies this is one point, this is the other. So we're going to find it right here. And this can be a little bit daunting. It's pretty long. We do it a lot. But take your time and you'll see some tricks that'll make it quicker. So it says find the distance between these 2 points. And I'm going to label them. Guys, this is the same thing when we find slope with y2 minus y1 over x2 minus x1. Just label them. x1, y1. I'm going to say that's point number 1, x2, y2. Now, the order doesn't matter. I could have said this one was the 2's and this is the 1's, and it will still work. So let's start off by saying distance equals a big square root sign here. Let's see, it says x2 minus x1. That's negative 2 minus 2 squared plus, see the next part says y2 minus y1. Let's see, my y2 is negative 1 minus y1 looks like it's negative 1. Watch your parentheses here, guys, and don't leave off your squareds. So do this in steps. I would not put that in my calculator. Negative 2 minus 2 is negative 4 squared plus negative 1, and we got a boom, boom. Negative 1 plus 1 is 0. Now, I need you to pay attention. This is something people screw up all the time. You have to have parentheses around these things right here. If you put negative 4 squared into your calculator, it'll tell you it's negative 16, but we should know that anything squared is positive. So if you do this, the calculator knows what you're talking about, okay? Well, when I put it in the calculator, if you even need to, negative 4 squared is 16. 0 squared, 0. The square root of 16 gives us a length of 4. So it's a pretty easy problem. Just watch out for the little things I was saying. Watch out for the minus, the negatives. Watch out for your squareds. Don't take the square root until the last possible second. Now this one's just a little bit harder because if you count wrong, you're going to get it wrong. Remember, this doesn't have the line over it, so that means it's looking for the length of AB. So first we have to find A, point A. Let's see, that's 2, negative 3. But we also need to know B, which looks like it is 4, 5. Count carefully when you do these on your homework. I'm going to label these as x1, y1, x2, y2, and we are right back where we started, okay? So let's see, square root of, looks like we're going to have to do x2 minus x1, 4 minus 2 squared, plus y2 minus y1, 5, minus negative 3 squared. So again, we have a boom, boom. Let's do this in our heads. I don't think we need to do much. 4 minus 2 is 2, so we have 2 squared. 5 plus 3 is 8, so we have 8 squared. 2 squared is 4. 8 squared is 64, so we end up with the square root of 68, which for the moment I'm okay with. But we do need to know how to simplify that. I don't know if you know how to do that or not yet, but I will show you just in case. That's actually 2 square roots of 17. If you're not sure how we got to this point, don't worry, we will go over it. This is fine, or its decimal approximation, which would be like 8.2 or something like that. But for right now, that's okay because we have lessons on the other. Let's go ahead and go to the next part. It says, examine the measures of PQ, QR, and PR in example 2. And notice that 1.5 plus 4.5 equals 6. So what that means is that if I took PQ, a piece of the line, and added to it QR, the other piece of the line, it equals magically the whole thing. That seems really easy, but it's something people mess up on. And it actually gives us our first big postulate. And I want you to put a big star by that. The segment addition postulate. It says if Q is between P and R, so here's P and here's R, and then Q is in here. It says if you add up this piece to this piece, you get the whole thing. It seems pretty easy. It actually is. Just remember what it is, the segment addition postulate. It says on example 5, if B is between A and C, so I'm going to draw that. Here's A. It says B is in between that and C. It says from A to B is 4 and B to C is 5. How long is it from A to C? I hope that we can all get that is 9. You just add them together. Now, it's been a while since we've looked at X, I'm sure. We're going to use some variables here. This might be a little trickier, so I hope you remember your Algebra 1. It says if AB is X and BC is X plus 6, and AC is 24, find AB and BC. Now, they're using the same picture we used up here where B is between them. So a picture is pretty pivotal here. So let's see. There's A, B, and C. From A to B, it's X. From B to C, it's X plus 6. And then, of course, they tell us the whole thing from A to C is 24. Now, this has variables in it, but if you remember, the pieces added together equal the whole. So let's do that. X plus 6 is the same thing we did up here as adding 4 plus 5. It's just now we actually know what it equals is 24. So now I can solve this, find X, and find everything else. So 2X plus 6 equals 24. we would subtract 6 from both sides and get 2x equals 18. And when we do that, we divide both sides by 2. We get x equals 9. Now, that doesn't mean we're finished because it didn't ask us for x. It wants to know the length of AB and BC. So we plug that in. Well, AB is 9. It's just x. Then we have 9 plus 6 for BC. 9 plus 6 gives us 15. Just to check it real quick, these two should add together to be 24, and they do. So we're good to go there. The last one, same sort of thing. It's a little bit trickier. This is the one that my kids had the worst time with last year. It says find LM if L is between N and M. So I've got M there, N, and then L is in the middle. It says from N to L, it's 6x minus 5. It says from L to M, it's 2x plus 3. And then it gets a little weird from the last one. It tells us that the whole thing is also a little function, 3x plus 13. So, but the thing, it looks different. It doesn't have any actual numbers, like starting off like the whole length. But I still know that if I add up the pieces, it should equal the whole. So let's add up the pieces. 6x minus 5 plus 2x plus 3 equals 3x plus 13. So that's a big, long expression there. Let's see, 6x plus 2x, if we combine like terms, is 8x. Negative 5 plus 3 being minus 2 equals 3x plus 13. Guys, I'm going to do 2 steps at once here. If this bothers you, I'm sorry. I'm going to subtract 3x from both sides, but at the same time, I'm going to add 2. This should clean it up for us. Let's see, that gives us 5x. Let's see, those will cancel, It gives us 15. We divide by 5, so x is 3. Now again, that's not what they asked us for. They asked us for the length of LM, so let's plug that back in. 3 times 3 is 9. LM, I'm sorry. I was finding the whole thing. How about 2 times 3 is 6, plus 3 gives us a length of 9. So guys, if you have any questions, of course, come and ask, and good luck.